Hi everyone, I'll take you through Latency Lens, which is an AI automated prompt optimization for long-haul networks. I'll preface this by saying, across global networks, even small mismatches can trigger latency, outages, and costly errors. Data travels thousands of kilometers, but what happens when the distance our systems believe doesn't match reality? That's where Latency Lens steps in. Today, every circuit is unique, every discrepancy is manual. Engineers coordinate across teams to verify cable paths, round-trip times, and formulas, losing time and consistency. Latency Lens replaces that manual loop with one unified AI lens that continuously detects, analyzes, and learns. It assesses the what and generates the relevant distilled prompt to use in its reasoning, determines the how by identifying patterns to generate meaningful output. This relies on a hierarchy of truth. The hierarchy of truth starts with a distilled prompt that assesses the fundamentals. As an example, what is the source of your long-haul cable and what is the destination? That could be Johannesburg to Marseille. What is the geo-length that the polymodeling in your tool tells you is for the cable? What is the measured RTT that your system is measuring, which should be an immutable ground truth? And then what is the estimated RTT? This is an estimate based on the slack in the cable, and the slack could be different based on whether it's underground or subsea or both. Now, using that, it validates the measured round-trip time against the estimated round-trip time, and also validates the geo-length and path models, applies terrain and slack modifiers, and determines whether measured and estimated round-trip time, that I'm calling RTT, truly align. If yes, great. If they do not, then it validates the supporting data, compares the geo-length and the path models to ground truths, and applies modifiers. What do these modifiers mean? So, as an example, we have terrain. In heavily mountainous areas like Japan, this is critical. We also have seismic plates that play a role in this. In densely populated metropolitan areas, there is metro tax, as it is hard to navigate the cables through those areas, and enough slack has to be left there in case of things like road repairs. Then the subsea slack might look different based on where the cable is laid. It does a diagnosis and generates a recommendation. The diagnosis could range from an under or overestimated length or segment of the cable, incorrect path polymodeling, a data entry error, or a missing geosegment. The output is valuable for both engineers and leadership because it generates metrics on which percentages of anomalies are there across the entire set. This shows commonalities on what could be causing the errors. Now, we not only notice efficiencies, but we do have increased velocity, reliability, and cost savings over time, as not only man hours are saved, we have AI recommend on how it should be self-improved, and also this informs acquisitions or cable remodeling that could be costly in many situations. Now, the overall vision ranges beyond long-haul networks. It can be extended to intermetro networks, intrametro networks, operations, reliability, name it. And I will walk you through this in a bit more detail. Now, if these are your tools or your databases that you rely on, these could be modeled as single AI agents, but this is not what we are proposing. Latency Lens is a layer of orchestration across all tools to remove the silo operation. It looks at them as a unified lens, generates a distilled prompt and modifiers, and through continuous reasoning, it's always able to self-improve and also prompt you for better data on how, or in case there is any challenge or in case there is any hallucination. Like everything, it's not perfect. When the output is generated, it's insights on what should be done, root cause analysis, what should be, how this can be proactively prevented in future, and alerts to act before customers can experience an outage. And this could inform how traffic should be rerouted. Now, the recommendations are also provided, and these can then inform future feature improvements in tooling. And maybe one tool might not be necessary over time. So you do not need hardware at your premises to have this solution. It's cloud native. You are able to have corrections in minutes and not hours. And as the tooling improves, you're able to see on-time assessment of inaccuracies and discrepancies, which will eventually keep your networks honest. Thank you.